So good afternoon, everyone. I bring you yet another tutorial today, which happens to be your tutorial sheet in mathematics, tutorial sheet 1, and hope you'll be able to learn something. To those of you that have not yet subscribed to my YouTube channel, make sure that you subscribe and you'll be able to learn something from there. Also, don't forget to hit the like button and share to others. So we have a question which is saying, given that U is equal to this particular set, I'm sure you've seen the sets that are there. Now they want us to operate the following given sets, what they're saying, X union Y. So now, okay, let me do this. So we'll start with the first question. They are saying that X is a set of even numbers. They're saying even numbers in U. So X is equal to, what are the even numbers in U? In U, we have even numbers of 2, we have a 4, we have 6. Okay, so these are the even numbers in X. Then in Y, we have been told that the prime numbers in U. So in U, we have prime numbers of 2, 3, 5. All right, so we have this particular set. Then they are saying that Z is this set, 5, then 6. Now we perform these particular sets given. So for the first one, they are saying we find X union Y. So now this simply means that we're combining whatever is in X with those in Y. So the answer is going to be a 2, 3, 4, 5, 6, and 7. Okay, so that's the answer for the first question. Then we come to B. They are saying X intersection Y, then complement. So what they just want us to do here, we are going to find the whatever we have found here, then we are going to remove these values and consider whatever is going to remain. So when we remove these values, we are going to remain with okay, so we say X intersection Y complement. If we remove these values, we are going to remain with -2, -1, 0. So we remove 2. Okay, do we have 1? Okay, we have 1 like this. We've removed 2. We've removed 3. We've removed 4, 5. We've removed. Then we've removed 6. We've removed 7. So if you check, these are the only values that you are going to remain with. Okay, so make sure that you also follow well, so that even if I make a mistake, you'll be able to get what's there. So if we remove these values, okay, this is simply the complement. Okay, complement simply means when you remove these values, what you remain with, those are the numbers that you are going to consider. Okay, so remain with these values. Now they are saying we find X intersection this. So we have C saying X intersection Y slash Z, like this. So the first thing we're going to do, we're going to consider whatever is in the brackets. So we say X.
How are you?
Fine, how are you? I. Okay, so Y slash Z. So now Y slash Z, when you have something like this under sets, this simply means that whatsoever value that is in Y, which is not in Z. So what are the values that are in Y which are not in Z? So we have a 2. No, here we have 3, so not 3. Here we have 5, not 5. So here we have 7, here we don't have 7. Therefore, we are going to have a 7 like this. So now they are saying that X intersection this particular set, like this. So now, what are the values in X and also in here? Which value is appearing? So we discover that we only have 2. Therefore, the answer is going to be a 2, like this, okay, for this particular question. Now they are saying, D is saying we find the cardinality of X union Y, okay. So now X union Y, we found it to be, let me just list it. It was 2, 3, 4, 5, 6, 7, like this. So cardinality simply means we count the numbers in here, then that is simply our answer. So we have 1, 2, 3, 4, 5, 6. So our cardinality is simply a 6. Okay, go to the next question. Okay, the next question is simply saying, which happens to be question 2. Okay, so maybe before I even go to the second question, I think I will need to redo B because I'm not really comfortable with what I've solved so far. So B was saying we have, they're saying we find X intersection Y complement like this, okay. So the first thing to do, we work out what is in here. So we're going to find the intersection of X and Y like this. Okay, I find the intersection of X and Y. So now X, we have this particular set, Y, we have this particular set. So X intersection Y, we have something like 2, let's just have 2. Okay, so we have 2. Then here we have 2 as well. We have 6. We have 6. We have 6. So this is going to be this set. Then they are saying complement of this set. It means we're just going to remove 2. Then we're going to remain with negative 2, neg 1, 0, 1, 3, 4, 5, 6, and 7. Like this. Then we have found the correct answer. We have found the correct answer. So now we go to the second part. The second part is saying, let R be the universal set. Okay, so R, we can simply say R is simply some set maybe from negative infinity to positive infinity. Okay, I use these brackets like this. Then they are saying that D is this set. Okay, this set. Okay, then they are saying that E is this particular set, like this. Then they are saying that F, now F is a set such that it is in set Buida notation. It is a set of X such that X is less than 10, and then X must be a member of all real numbers. So this simply means that this is going to be a set which is coming from negative infinity, then going to some 10. Now the brackets that you use are these ones. Okay, so use these brackets. This simply means that 10 is included. This simply means that this is not included. So 0 is not included. This is not included. Okay, so then these ones simply means that these numbers are independent of each other. Now the question is simply saying, find the set E slash F and display it on the rule line. Okay, so now let me find this one. So A, the first thing to do, you are going to get a rule, then you draw a line like this. Okay, draw a line, this kind. Okay, now this line we know that is coming from neg infinity, then it's going to positive infinity like this. Now, since we are dealing with E and E slash F, we are going to get E first. Now, we know that this in E, E, we have a 0, then we have 8, like this. Then we know that in F we have -7, then we have a 4 here. So now what you do, you get a rule, then you're going to write the first letter that you have been given. So they are saying E, so we're going to draw a line for E. Now E is coming from 0. Now check the brackets, they are not including 0. So we're going to draw an open circle here and an open circle here. Then we draw a line like this, okay? Then for F, we are going to draw an open circle from here. Then, since they are saying 10 is included, we can put a 10 here. We are going to put 10 somewhere here. Okay, so we're going to put a dotted point like that to show that it's included. Then from there, they are saying that E/F. So slash simply means that E complement of F. This is simply the same as E intersection F complement. Now F complement, we are simply starting from here. So we'll draw an open circle like this and take it this side. Okay. We'll also draw an open circle here, take it this side. So now this is F complement. This is also F complement. Now when you check, there is nowhere where this set for E and this set for F are intersecting in terms of their complements, because this is starting from here going this side, this is from here in between. So these two are not intersecting anywhere. Therefore, we can simply say that E/F is an empty set. Okay, so it's an empty set. That is the answer for this one. Okay, now for the second part, they are saying, using the sets above, verify that D complement intersection E complement is equal to that. Okay, so I'm going to demonstrate on the other side. Now for this one, we are going to use the same concept. We're going to use the same concept. Okay, so the concept that we are going to use is this. I'm going to draw this particular set here. So I'm going to draw something like this. Something like this. Now, we are saying that the universal set is from negative infinity to positive infinity like this, okay? Then we can say that our first set is going to be, D is from -7 to 4, so we can put something like -7 here, okay? Then we can put, what's this, a 0 here. We can put a 4. Okay, so where was I? Okay, so now we are going to display this information on the rule line, and you will be able to see how I'm going to do this simple question. Okay, so now the first thing that I'm going to do, I'm going to draw a line for D. Now they are saying, okay, so before I even do that, let me finish the rule line. Then we have been told that in E there is 8, so there's 8 here. Then we have been told that we can also have 10. We have 10 here. Okay, just this. Now we display the information. Now for D they are saying that we have an open circle at -7. Then we are also going to have a cross circle at 4. So we are going to open the circle here, then cross the circle here, like this. Okay. So I'm going to draw a line, then I name this one D. Okay. Then for the second part, we have been told that we have E is from 0. So since these are brackets which are like this, so this simply means that these numbers are not included. So I'm going to open the circle at 0. Then I'm going to also open the circle at 8 and draw a line of this kind. Then I'm also going to consider F. Now they are saying that F is from -infinity. So I'm going to open a circle here. Then I'm going to close the circle like this at 10. Okay, like this. I'm going to do this. Okay, So now, this one was E, this was F. This is the universal. Now, they are saying that using the above, verify that D complement intersection this complement is equal to that. What we are simply doing here is also what we call De Morgan's law or De Morgan's theorem. Okay, just want to prove this. It's very simple. So now they are saying that we can find D complement. That's the first thing to do. So we can say left hand side. Okay, so we do the left hand side like this. So for the left hand side, we are going to prove this side, then also prove this side. But then we are going to start with the D complement. Now D complement is simply, since here there is a closed circle, there is an open circle. This time around, I'll cross the circle and write it like this. Okay, so this is D complement like this. Then here there's a closed circle, so I'm going to open the circle like this and write this one. So I'll take it this side up to where there is infinity. So I'm going to write this one as my D complement. Therefore, D complement is coming from negative infinity up to 7, negative 7 included like this. Then union, then I start from here. So this was 4, then open, then comma, then this is going to be like this. Okay, so I'm sure you've seen what I've done. Then I'm also going to find E complement. Now for E complement, since this is an open circle, I'm going to draw a cross circle here. Then I'm going to take it this side, okay, up to where there is infinity. So this is going to be my E complement. Then I'm also going to draw another line from here up to this side, and I can name this one. So this is going, since this is open circle, this is also going to be a closed circle. So I can name this one as my D complement. So, okay, where are we? So this is E complement, of course. So E complement is going to start from, negative infinity to 0, included like this. Okay, 0 included. Union, then I open the brackets. Where is this starting from? It's starting from here. So this is going to be 8 included, then something like this. Okay, so now the intersection of D complement intersection this guy, this is simply, since from here to here we have, we know that 0 is between, we know that this negative infinity to this union this, if we intersect it with this guy, then automatically we are going to find that it's going to be negative infinity reaching to where 7 is. Then we say union, then it's going to be 8 like this. Okay, so this is the left hand side. So now we can also do the same to the right hand side. Right hand side. Okay, so the right hand side is saying we prove that D union E complement is equal to this. But then we know that if you use the same concept, you intersect U with E first, then you find the complement of these guys, you are also going to discover that you're going to have something like negative infinity, comma, negative 7, then U, then 8. Okay, I think I've shown you the concept. So here you're going to close the bracket, then open the brackets like this. Therefore, you have simply shown that D complement intersection E complement is going to equal to D union E complement. So this is simply what we call the De Morgan's law. So make sure that you do the other side. It's very simple because I've shown you how to do the left hand side. Okay, we have the third question. Okay, the third question, where is it? The third question is simply saying, okay, where is it? Okay, the third question is saying, for each of the following sets, state whether it is finity or infinity, and in each case justify your answer. So we start with A. Now, I think I taught in my previous video, I was able to teach you what a infinity set is all about. So this time around, I think we'll just be passing there. So for A, we have been told that A is a set of from 0, 1 intersection R, where R is simply a real line. So in other words, 0, 1 intersection R, these are independent variables, is simply 0, 1. So here the answer is simply 0, 1. So now these are countable numbers. Therefore, this is a finity set. We go to B. B, they are saying X is such that it's a member of all real numbers where X squared is equal to 4. For this one, what you're supposed to do, you are going to say X to the power 2 equal to 4, then X to the power 2 minus 4 equal to some 0, like this. Then you are going to find the difference of two squares, which happens to be X minus 2, X plus 2 equal to 0. And your answers are going to be X equal to 2 and negative 2, like this. So we can prove this on the rule line. You do this on the rule line, and then you put 2, negative 2 like this, then you put 0, you put negative 2 like this, you put negative infinity, you put positive infinity like this. Okay, you put positive infinity like this. So now you discover that you're going to have some value which will be ranging from this particular point to this side, and value which is from this point to this side, and the values between these points. Okay, so if you test these values, in this equation, any number that you raise to the power 2 is not going to be less than 0 this side, because if you get negative 8 to the power 2, it's going to be positive 64, so it won't be less than 4. So these numbers are cancelled, but only these numbers are going to agree, because when you raise this to the power 2, it will give you some 4, okay? Some number at least less than 4. But this side, it is also going to cancel. It won't agree. Okay. Therefore, the only numbers that you're going to remain with are negative 2, 2 using these brackets. Okay. Now this set is not it's not finity, because we are using this bracket. This simply means that we are also considering some numbers in between negative 2 and 2. Therefore, this is an infinity set. Okay, infinity set, like this. Very simple. Okay, so we get to C. Now for C, they are saying that we have this particular set, intersection, then 4 over 3, 3 over 2. Now for this one, it's very simple, because we know that we have 0, 1, then this is 4, 3, 3, 2. If you divide these numbers, you will find 1 point something, 1 point something. We don't have any 1 point something in here. Therefore, this is an empty set. Okay, now an empty set, remember in my first video, is considered to be finity. So this is a finite set. Okay, so you can do the last question. It's quite simple. We get to 5. Which of the sets listed below are equal to other on the list? No, this is very simple, so I won't be able to do that one. I will leave it for my students. I'll leave it for you to do. Let me just do the last part. So the last part, I think I'm going to do C, so that at least you'll be able to learn something from there. Okay, so the only thing that you are supposed to do here is to ask yourself, where are they intersecting? For example, this one, these two are not intersecting anywhere, because we have 1 is considered, 2 is considered in here, but here 2 is not considered, 3 is not considered. So there is nothing that is intersecting here, so we won't consider anything. But when you check here, we have 2 in here, we have 2 in here. These two are intersecting somewhere. Therefore, you can say that these two are intersecting at 2. In here, 1 is considered, 3 is considered. These are independent variables. 2 is considered, 3 is considered. So these two are intersecting at 3. So the only sets which are equal are this one and this one, because at least they are intersecting at some point. That is, if you try to solve, you try to prove, you find the same concept is able to prove it on. So we get to 6. I think I'm going to prove. Should I prove all these? I think I showed you how to do this one. I showed you how to do this one. Which one should I do? Okay, so you're going to, these ones, I think you know how to do them. They're simple. So I'm going to do C. Okay, so now we have the root of 3, then the root of 2, and we are taught to prove that this is irrational. So like I said, the method we use is the contradiction method. So we are going to assume that the root of 3 plus 2 is rational. Okay, contradiction method. Then we say where, okay, then if that statement is true, then what we are simply saying is that this is going to equal A over B, where A and B are integers, okay, integers, and B is not equal 0, like this, okay? So now this is just the same as the root of 3 plus root of 2 equal to A over B. You can square this side and square this side, square this side and square this side, like this. Now, if you multiply this, you expand it like this. I can expand it like this. You're going to discover that you're going to have a 2 to the power 2 here, A to the power 2 over B to the power 2. Now, this multiplied by this is simply 3 plus this multiplied by this. This is going to be a root of 6 plus this multiplied by this, root of 6 plus this multiplied by this, it is simply 2, then equal to A squared over B squared. Now this is going to be this plus this, you know, sets, so this is 2 root 6 plus 5 equal to A squared over B squared. Very simple. From here, we can say root 2 root 6 equal to A squared over B squared minus 5 over 1. So this is going to be 2 root 6 equal to, okay, then this into this, it is A squared minus this into this, it's this. This multiplied by this, it's going to be 5B squared. Now check, we can say over 2, even here we say over 2. So we're going to have the root of 6 equal to A squared minus 5B squared over 2B squared, like this. Now, we know that these are all positive integers, okay? These are positive integers because whatsoever value you put here, it's going to hold. Therefore, this side is rational. But then we know that root of 6 is irrational. The square root of some number which cannot be expressed in the form A over B is irrational. Therefore, this side is irrational. Therefore, meaning this equal sign is not able to hold. So therefore, we have proven that the root of 3 plus 2 is irrational, like this. Thank you so much.